So yes, as Jan mentioned, I'm Nimrod from Onwrks. Before that, I was a wind turbine service technician. Now, being a service technician on wind turbines, you often get a phone call in the middle of the day saying, "Hey, what are you doing? We have a turbine broken down somewhere. We need you to go now." And I usually would pack my bags and drive to the other side of the country. And in this job, you really get a chance to see how many turbines are underperforming in the industry today. Probably the most common reason for turbines to underperform is yaw misalignment. See, all turbines today are designed to detect the real wind direction and face into it for maximum output. The problem is that in reality, the majority of turbines fails in doing so, and as a consequence, the European wind industry loses about 420 million euros every year. And this is only one of many examples how turbines can fail. But really, we can break all these examples down to two main pain points for the wind industry. So unplanned maintenance, the type that they'd call me up in the middle of the day, is the majority of maintenance today. And underperforming wind turbines end up costing the wind industry about 10% of their revenues. Both together add up to 4.5 billion annual revenue loss to the wind industry, and this number will double itself by 2020. So today the wind industry tries to fight that by adding more hardware and more sensors on their turbines, or sending teams on site to conduct further measurements. Now all that, when every turbine comes equipped from day one from the manufacturer with a SCADA system, so essentially a bunch of different sensors all over the turbine from all different components that send back hundreds of parameters to the operations rooms every 10 minutes. And all this data just aggregates on the servers of the operators and owners. And that's really where we come in, where Onwrks come in. We're developing software for smarter wind turbines. So essentially, what we asked ourselves when we started working is, could we find a correlation within all these different parameters that would indicate the failures that I mentioned before? And the answer since then we've discovered is yes. What we've developed is a set of deep learning algorithms that takes this SCADA data and this data set that exists on the servers of the owners and turns it into, and use it to indicate some of the wind industry's biggest problems today. So let's go back to the yaw misalignment example from before. So today, to detect a yaw misalignment, you'd have to send a team with different lasers and different instruments, and they'd climb on the turbine, they'd put their gear there, and they'd conduct measurements for about a month or so. And then they'll tell you how much your turbine is misaligned to the wind. Now, what we do is we give you the same result, but we use the data that exists already in the servers of the owners, and we can do that in real time. In the future, our clients will be able to interact with our algorithms and our solutions through an online platform. So essentially, we'll be providing a fully software solution that is easy to implement, uses existing data sets to predict maintenance and optimize their assets. Today, we're already working with several local turbine operators in the proximity of Berlin. Some international turbine operators as well are joining us now, and utilities from outside of Germany, all of which we're helping to optimize really their assets. We're now in the middle of our seed round, so any early stage investors out there, I want to reach out and say, let's talk. But also anyone else that is interested in what we do, please feel free to contact us.